Today we're going to be learning about absolute value equations and inequalities, section 1.6 from the Algebra 2 book. Our objective is that we can write and solve equations and inequalities involving absolute value. Now remember absolute value, when we use an absolute value symbol, our answer is going to be non-negative, which means 0 or a positive number. Since opposite numbers have the same absolute value, an absolute value equation can have two solutions, such as the one that we see in this take note box. You can see absolute value 4 is equal to 4 and absolute value of negative 4 is equal to 4. So when you're solving an absolute value equation or inequality, you can get two solutions. And remember, the definition of absolute value is the distance from 0 on the number line. So you can see on this number line below that we have absolute value 5 and absolute value of negative 5. Both of those points on the number line are 5 units away from 0. So in example 1, we have the absolute value equation 2x minus 1 equals 5. We need to graph that solution after solving it. The first thing you want to do when you have an absolute value equation is get rid of the absolute value symbols. So if we're saying that 2x minus 5 is 5 units away from 0, we need to set 2x minus 1 equal to positive 5 as well as negative 5. And then from there, it's just a basic two-step. So we're going to add 1 to both sides, and we're going to divide by 2, and we get x equals 3 or x equals negative 2. Now we're going to graph that. So make a number line and put a point at negative 2 and 3. And we are having closed circles because we are including those values. And now the checking process. I think you're used to this from previous problems. What you do is you take the answers, 3 and negative 2, and you separately input them into the original absolute value equation. So we're going to see if 2 times 3 minus 1 is equal to 5. We find out that the left side works, 5 equals 5, and also the right side works, 5 equals 5. So that means that 3 and negative 2 are valid solutions for this absolute value equation. Here's example 2. What is the solution of 3 times the quantity of absolute value x plus 2 minus 1 equals 8? Graph the solution. So before we set it equal to positive and negative value, we need to isolate the absolute value expression. So we're going to add 1 to both sides, and we get 3 times the absolute value of x plus 2 equals 9. And then we're going to divide by 3 so that we isolate the absolute value expression. Absolute value of x plus 2 equals 3. Now, this is pretty similar to example 1. We're going to have x plus 2 equals positive 3 and x plus 2 equals negative 3. And then from there, it is a one-step equation. So we're going to subtract 2 from both sides for both equations. And we get x equals 1 or x equals negative 5. Make yourself a number line and plot the points, negative 5 and positive 1. Similar to the previous problem, the checking process, you just take those two values separately and put them in for the variable x and check to see if they work, and it turns out they both do. So those are both valid solutions of the original equation. Now remember, distance from 0, which is absolute value. Distance from 0 on a number line cannot be negative. So when we have an absolute value equation, you need to make sure that it's isolated, which means there's nothing else, no numbers outside of those absolute value symbols. If this absolute value equation is equal to a negative number, then that means there's no solution because it's not possible to have a negative equal to an absolute value equation. Here's an example. If absolute value of x is equal to negative 3, we know that there is no solution. Because when you plug in a positive or a negative value for absolute value, you get a positive number out. Here's something important you want to remember. You want to check all solutions of an absolute value equation. Sometimes the solutions are extraneous, and now we're going to talk about what that means. An extraneous solution is a solution derived from an original equation that is not a solution of the original equation, which means when you check your answer, it doesn't work. So if this ever happens to you, which you will see, that's an extraneous solution. But for the solutions that do work when you check them, those are valid solutions. Here's an example. Example 3. What is the solution of the absolute value of 3x plus 2 is equal to 4x plus 5? Check for extraneous solutions. So similar to the previous couple problems, the first thing that we want to do, make sure the absolute value equation is, or the expression is isolated. It is. So now we're going to set 3x plus 2 equal to positive 4x plus 5. And we're also going to set that equal to negative 1 times 4x plus 5, because remember, we're taking the positive number and we're taking the negative number. And then from there, it's like a multi-step equation, so we just need to isolate the variable for both of them. We are going to subtract 3x from both sides and then subtract 5, and we get x equals negative 3. So this is a possible solution. We'll check in just a moment. Now in the next one, you want to share the negative 1 in front of that parentheses, and we get 3x plus 2 equals negative 4x minus 5. Add 4x to both sides, subtract 2 from both sides, divide by 7, and you get x equals negative 1. So negative 1 is another possible solution. Now remember, in order to check to see if these are extraneous solutions, we need to plug in negative 3 as well as negative 1 and for the original equation. So that's what we're going to do now. So you can see my work below. We find out that 7 is equal to negative 7. That's a false answer, a false statement. So that means that x equals negative 3 is an extraneous solution. So that's what is hidden under the screencast-o-matic picture in the video. Now on the right side, it does work. So that means that x equals negative 1 is a valid solution, and that is the only solution to the equation. Okay, now we're going to talk about absolute value inequalities, which is a little bit more involved than absolute value equations. Now, please recall from the previous lesson video 1.5, we learned about and or inequalities. Now we're adding the absolute value concept. Here's a basic example. We have absolute value of x is less than 5, and absolute value of x is greater than 5. So absolute value of x is less than 5 means that x is within 5 units away from 0. The other one, absolute value of x is greater than 5, means that x is at least 5 units away from 0. So beyond 5 units away. So now we're going to rewrite this without the absolute value symbols. So we have x is less than 5 and x is greater than negative 5. Remember, this is an and inequality. So we're going to rewrite this in our condensed form. So you take the negative 5, which is a smaller number, put it on the left side. The bigger number is 5, so put it on the right. The x is in the middle because it's in between those two values, and the symbols are always pointing towards the left in this condensed form. Open circles on the endpoints, negative 5 and positive 5, and we're shading in between. That is where the x values are located. So you want to remember, whenever you have a less than symbol, it's going to be an and inequality. Now the other possibility is the or, and the or inequality we said earlier is 5 units, at least 5 units away from 0. So we have open circles on the negative 5 and the positive 5, and we're shading outside because they're going in opposite directions. So take note right here, if you have a less than or equal to symbol, it's going to be an and inequality, and if you have a greater than or equal to symbol, it's going to be an or inequality. In example 4, we have the absolute value inequality. Absolute value of 2x minus 1 is less than 5. Just like with equations, the first thing that we want to do after making sure that the expression inside the absolute value is isolated is to get rid of those absolute value symbols. So the first inequality is going to be identical, except without the absolute value symbols. And the next one is going to be the same on the left side, but we are going to make it -5, because remember we have positive and negative of that number on the right side. And when we change the sign, we also have to change the direction of the symbol. So this is the new part. Make sure you're paying attention. The first absolute value inequality stays the same, but the other one, the sign of the number on the right side changes and the symbol also changes. From this point, it's pretty similar to what we've been doing in the past, just isolating the variable. So you can see I did 2 steps for each of the inequalities, and I got x is less than 3, x is greater than -2. This is an and inequality because we have a less than symbol and the variable is on the left side, so make sure you bring down and. And for an and inequality, you can rewrite it in the condensed form. We talked about this in the previous lesson video. So the smaller number goes on the left, the bigger number goes on the right, and the symbols always point towards the left. So we have -2 is less than x, which is less than 3. Let's graph that now. I put an open circle on the -2 as well as a 3 because there are no lines underneath the inequality symbols, and I'm shading in the middle because it's an and inequality, so the shading is in between. For example 5, we have the absolute value of 2x plus 4 is greater than or equal to 6. I know that this is going to be an or inequality because of the greater than or equal to symbol. So first thing, like the last problem, is get rid of those absolute value symbols. So we're going to have 2x plus 4 is greater than or equal to 6, or 2x plus 4 is less than or equal to -6. And from there, it's 2 steps. So when I isolated the variable, I got x is greater than or equal to 1, or x is less than or equal to -5. And now we're going to graph those on a number line. I plotted the 2 endpoints, +1 and -5. They're both closed circles because the or equal to symbol is below the inequality symbol, and we're shading out or in opposite directions because this is an or inequality. Before we solve example 6, let's talk about what the word tolerance means. When we're manufacturing an item, tolerance comes into play. A manufactured item's actual measurements and its target measurements can differ by a certain amount, which is called the tolerance. Tolerance is basically how far away the actual measurements can be from the target measurements and still be produced. So the tolerance is 1/2 the difference of the maximum and minimum accepted values. So you definitely want to write that down. We'll be using that fact for this last problem. And we're going to be using absolute value inequalities to describe this tolerance. Here's example 6. In car racing, a car must meet specific dimensions to enter a race. Officials use a template to ensure these specifications are met. What absolute value inequality describes heights of the model of race car shown within the indicated tolerance? So you can see in the picture, the desirable height is 52 inches, and I encourage you to draw a picture similar to this. And the greatest allowable height is 53 inches. The least allowable height is 51 inches. We need to make an absolute value inequality that describes this relationship. So, like we talked about above, we need to find the tolerance, which means we take the max value and subtract the min value and divide by 2. The max value is 53, the min value is 51. 53 minus 51 is 2. 2 divided by 2 is 1. That means the tolerance is 1. So the height can be within 1 inch of the desired height. Because the tolerance is 1, we know that the height can be 1 inch above or below the desired height of 52 inches. So that's why I have -1 on the left side and +1 on the right side. And then 52 is the desired height of the race car. H stands for the height of the car, and this is our compound inequality. Because the height has to be within 1 unit of 52 inches, we're going to be using the less than or equal to symbol. Remember, less than or equal to symbol relates to the and inequality, and it makes sense because the height needs to be between 51 and 53 inches. So here is our absolute value inequality. Absolute value of h minus 52 is less than or equal to 1. Here are our lesson check problems for section 1.6. Write these down, show your work. Box your answer and let me know if you need any help.